Imagine driving on a highway where your vehicle is entirely swallowed by the clouds. You look out the window and instead of seeing the ground, you are staring down into a terrifying, seemingly bottomless abyss. This is not a concept from a science fiction movie. This is the staggering reality of the Beipanjiang Bridge, also known as the Duge Bridge, located in the remote mountainous borders of China's Guizhou and Yunnan provinces. Suspended an unbelievable 565 meters, or 1,854 feet, above the roaring Beipan River, this megastructure shattered every known boundary of civil engineering when it claimed the title of the highest bridge on Earth. To truly grasp the scale of this terrifying height, imagine taking the entire Empire State Building, from its base in New York City all the way to the tip of its lightning rod, and placing it directly underneath this bridge. The massive skyscraper would fit perfectly into the canyon, and there would still be an astonishing 120 meters of empty air left between the top of its antenna and the cars driving on the bridge deck above. For years, the world's greatest engineering minds looked at this massive, violent gorge and declared it unconquerable. The cliffs were too steep, the rock was too weak, and the weather was too brutal. Yet, Chinese engineers not only conquered the abyss, but they also achieved what many called an absolute impossibility. This is the incredible full-process story of how an army of engineers and workers battled unstable mountains, defied gravity, and spent over $100 million to build an impossible highway in the sky, turning a treacherous 5-hour death-defying mountain journey into a breathtaking 3-minute flight above the clouds.
Clear the exclusion zone. Final warning, move back now.
All teams, all clear confirmed. Detonation in 30 seconds. Firing now. Look at the lamination visible on this scar. We need samples from the contact zone.
Noted. I'll bag these immediately. Check the displacement sensors on Block 12.
Readings are stable, Supervisor. It's splitting exactly as modeled.
Look at the interlocking crystals. This is exactly what we hoped for.
The compressive strength is excellent. The hammer barely leaves a trace.
Get that vibrator deeper. All right, pulling it out now.
Before a single piece of steel could be laid, engineers faced a geological nightmare that threatened to stop the mega project before it even began. The Beipan River Gorge is entirely composed of karst limestone. While this type of rock creates the breathtaking, otherworldly mountain landscapes that southern China is famous for, it is the absolute worst possible foundation for heavy infrastructure. Karst limestone is incredibly brittle, highly porous and riddled with hidden unpredictable subterranean cave systems, sinkholes, and deep vertical fissures created by millions of years of water erosion. If engineers were to simply place the massive bridge towers on the very edge of the canyon cliffs, as is standard practice in bridge construction, the sheer, concentrated weight of the concrete and steel would have triggered a catastrophic structural failure. The cliff edge would have literally sheared off, sending hundreds of thousands of tons of rock, and the bridge itself, plunging half a kilometer down into the river below. To prevent this devastating scenario, the engineering team had to make a radical decision. They could not use the cliff edge. Instead, they had to retreat inland and physically anchor the colossal bridge towers deep into the solid mountain rock face itself. But moving the towers further back meant the bridge span had to be significantly lengthened, drastically increasing the weight and tension that the structure would have to support. Workers had to detonate thousands of controlled explosions to carve deep, massive foundation pits into the sides of the mountains, carefully removing the weak outer layers of limestone to reach the highly compressed, ancient bedrock underneath. Every blast had to be meticulously calculated. A shockwave too powerful could destabilize the entire mountain face. Once the bedrock was exposed, engineers poured thousands of cubic meters of specialized high-strength concrete to create an indestructible root system, locking the foundation into the mountain so tightly that it essentially became a living part of the local geography.
Take it left, just a fraction. All right, easy now, we're almost home.
Clevis pin secured. Split pin in place.
Load tag confirmed. Clear for transport.
Control to base. Visibility is dropping to 50 meters.
Roger that. Keep it steady. Watch the sway. Take the measurement now.
0.83 hertz. It's stable.
Good, the tension is confirmed.
With the foundations finally secured, the towering concrete pylons began to rise from the mountaintops. These twin towers had to be absolutely massive to support the sheer length of the steel deck hanging over the void. Reaching a staggering height of 196 meters, taller than a 60-story skyscraper, these concrete monoliths became the architectural backbone of the Beipanjiang Bridge. But as they rose into the sky, observers noticed something peculiar, something that looked like a terrifying multi-million-dollar engineering mistake. The towering pylons were not perfectly straight. They were leaning. However, this was no error. It was a stroke of absolute engineering genius. The designers had intentionally engineered the towering pylons with a 0.5-degree inward rake, meaning they slightly leaned away from the canyon and back toward the solid ground. This microscopic, almost imperceptible angle was the secret to the entire bridge's survival. The Beipanjiang Bridge is a cable-stayed structure, relying on a complex web of 112 massive, high-tensile steel cables to hold the heavy road deck suspended in mid-air. Because the bridge spans such a massive distance across the canyon, the sheer gravitational pull of the steel deck creates an unfathomable 10,000-ton tension load that constantly pulls outward on the concrete towers. If the towers had been built perfectly vertically at a 90-degree angle, this immense 10,000-ton outward ripping force would constantly threaten to snap the concrete pylons like dry twigs over decades of metal fatigue and wind stress. By tilting the colossal towers backward by just half a degree, the engineers brilliantly used the massive weight of the concrete pylons themselves to act as a permanent, natural counterweight. Gravity itself was weaponized to fight the immense cable tension, ensuring that the towers remained perfectly balanced and structurally sound, even when battered by severe mountain storms and typhoon-level winds.
Slew adjustment required, 2 millimeters to the east. Hold position for coordinate verification. Next, lift 5 millimeters.
Approaching final alignment, 2 millimeters remaining. Copy that. Easy pressure on the jacks.
That's it, final torque achieved. Mark it yellow.
Keep an eye on the vibration sensors as we cross the joint. This is a historic moment for the project. Readings are steady. The closure is holding perfectly.
Okay, team, secure the receivers. Mission accomplished. Copy that. Packing the Giju tip now.
Check cable 112.
Reading is stable, 1.04 hertz. Verified.
Deflection at midspan holding steady at 12 millimeters. The results match the prediction. It's a success.
Designing the bridge was only half the battle. Actually building it in one of the most inaccessible regions on the planet was a completely different war. The Beipanjiang River Gorge is so rugged and isolated that absolutely no roads existed that could lead to the construction site at the top of the cliffs. You cannot build a megastructure without heavy machinery. But how do you bring 90-ton cranes, massive steel girders, and thousands of tons of wet concrete to a peak where trucks cannot drive? The answer was brute force, aerial logistics. The construction site essentially functioned like an active military operation. Before the main bridge could be built, engineers had to construct a massive, temporary suspension cableway high above the canyon. This complex system of heavy-duty pulleys and high-tension steel ropes became the lifeline of the project. Every single piece of equipment, every massive steel truss segment, and every heavy piece of machinery had to be individually airlifted or hoisted across the void using these temporary cable cranes. Operating these overhead cranes was a terrifying, high-stakes endeavor. Crane operators were blindly lowering steel segments weighing dozens of tons through thick, zero-visibility mountain fog, while brutal updrafts of wind from the canyon below threatened to swing the massive steel blocks out of control. Hundreds of highly skilled steelworkers and welders had to operate on narrow, swaying catwalks suspended almost 2,000 feet in the air, enduring freezing temperatures and terrifying heights. They secured the heavy steel deck piece by piece, inching their way out from the mountain edges toward the center of the abyss. One single misstep, or one failed cable snap, meant a 565-meter freefall.
Altitude is steady at 8 millimeters. No sympathetic movement on the adjacent line. Isolation confirmed.
Hold it steady. Lower it 5 centimeters. Now push it left, hard.
We are approaching the center span now. Keep logging the cable tension data. Look at the midspan reading. Only negative 4.3 millimeters.
Well within the limit. The structure is performing exceptionally well.
Slings engaged on the east side.
West side clear. Latch checked and secure.
Copy. Prepare for tension. Confirmed position lock. Initiating slew maneuver. Adjusting left, 0.1 degrees.
38,100 millimeters.
38,100.
37,800 millimeters.
As the two halves of the steel deck extended further and further out into the empty sky, approaching the critical closure point in the direct center of the gorge, a new, unforeseen crisis struck. To successfully connect the two massive halves of the bridge in midair, the alignment had to be perfect down to the millimeter. In standard bridge construction, engineers use high-powered laser surveying tools to align the heavy steel segments. But the Beipanjiang Bridge sits so high in the atmosphere that it exists inside its own weather system. Dense, impenetrable clouds, heavy mountain mist, and severe temperature fluctuations constantly warped and blocked the standard laser beams, rendering traditional surveying equipment completely useless. The engineers were essentially flying blind while trying to thread a massive steel needle in the sky. Refusing to be halted by the weather, the Chinese engineering team turned to the stars. They abandoned standard ground-based lasers and integrated China's advanced Beidou satellite navigation system directly into the construction process. By placing highly sensitive, military-grade satellite receivers on the extreme edges of the swaying steel deck, the engineers could bounce signals off satellites orbiting thousands of miles in space. This space-age solution bypassed the blinding fog entirely, providing the construction crew with real-time, three-dimensional spatial coordinates with millimeter-level accuracy. Guided by the heavens, the massive cranes gently lowered the final, crucial steel truss segment into the center of the span. Against all odds, the two halves of the bridge met perfectly in the middle of the clouds, locking together in a flawless steel handshake that permanently conquered the Beipan River Gorge. Today, the Beipanjiang Bridge stands not just as a vital artery of transportation, but as a towering monument to human audacity and extreme civil engineering. At the cost of over $150 million, this impossible structure took thousands of workers over 5 years to complete. But the economic and human impact of this mega project is truly immeasurable. Before this bridge existed, locals and commercial truck drivers had to navigate a treacherous, winding, and incredibly dangerous mountain road that descended deep into the valley and back up the other side. A grueling, exhausting journey that took over 5 hours to complete. Today, that exact same journey takes just 3 minutes. By physically bolting two crumbling mountains together and suspending a highway deeper than the tallest skyscrapers, engineers have permanently transformed the economy of the region, opening up isolated villages to the massive trade networks of modern China. The Beipanjiang Bridge is a testament to the fact that when faced with the absolute extremes of nature, human innovation will always find a way to rise above, literally driving through the clouds. If you were blown away by this impossible feat of engineering, make sure to hit that subscribe button, give this video a like, and let us know in the comments below. Would you have the courage to drive 1,850 feet above the abyss? See you in the next mega project breakdown.